All right, so today's lesson, we're focusing on the three primary trig ratios. So in general, these trig ratios are used to solve for either an unknown angle or an unknown side length. And they involve doing it for right angle triangles. So if you know something is a right angle triangle and you know it is a right angle, when one, you can see this square, but that square represents 90 degrees, okay? So if a triangle has a 90-degree angle, it is a right angle triangle. And you are able to use your trigonometric ratios. And we'll get to what those ratios are in a second. But first, let's label our triangle so the ratios actually make more sense, right? So when we label a triangle, we're going to label our side lengths here, right? So these are side lengths, opposite, adjacent, and hypotenuse. They're kind of like direction side lengths. It's us labeling like what side length represents what. And I know that sounds a bit confusing, but it's side lengths relative to an angle. Okay, so we have two triangles here that are identical. And in this first one, we're making a reference to angle A. And I want you to label the three side lengths opposite, adjacent, and hypotenuse. So those are the three options. Well, going across from the 90 degrees, in a triangle, in a right angle triangle, this will always be your hypotenuse, okay? So hip for short. And then opposite the angle that we're in question, the one that we're talking about, so this angle A, well, opposite that, this would be opposite. And then the one that it's touching, well, it's touching 2 technically, but it can't be this one because that's the hypotenuse. So then the other one it's touching, this is your adjacent. All right? So let's see what happens when we do it for relative to angle B. So this is angle B right here. Well, across from the 90 degrees always is our hypotenuse. But now, across from angle B, this side length is our opposite. But notice that in the exact same triangle, all right, these are identical triangles, it was the adjacent, and now it's the opposite. That's because your relative angle has changed, okay? So, depending on what angle you are using, your adjacent and your opposite, these can change, okay? The hypotenuse never changes. It's always the longest side length. And now let's just finish up the triangle here. The one that's touching B, well, this has to be the adjacent, okay? It's the only other option. So now, I kind of alluded to these three trig ratios. The three trig ratios are the sine ratio, the cosine ratio, or the tan ratio. And what these ratios do is they measure side lengths of a triangle, of a right angle triangle, okay? They give you the ratio of one side length relative to another. And each of these three primary trig ratios, I know I keep using this word ratio a lot, each one of these three options will give a comparison. Let me use the word comparison instead of ratio. We'll compare different sides of the triangle. So the sine is going to compare the opposite side length relative to this angle. So what you're inputting into your ratio, this is an angle. This is the ratio, the function, okay? It's going to measure, when you take the function of sine of an angle, you're going to get the ratio opposite over hypotenuse, okay? Or O over H. Well, cosine of an angle, well, that's going to give you your adjacent, and I'll just write ADG over your hypotenuse, hip for short. And again, you can also even shorten it for A over H. And then the tan will be the opposite side length relative or compared to the adjacent side length, or O over A. And the reason I gave you these even shorter forms, O over A and stuff, is because there's a handy saying. Well, the sine ratio, S, opposite over hypotenuse, so you call that SO, and then you have cosine, adjacent over hypotenuse, TOA, T, tan, opposite over adjacent. So this handy saying, which is SOHCAHTOA. Okay, it can help you remember what side lengths are involved in which ratio. So let's do example 1 and see how these ratios are used or set up. Okay, so state the primary trigonometric ratios for angle C, then calculate the measure of angle C. Okay, so this being the vertex C means that this angle right here is angle C. Okay, let's just be clear on that. So we are setting up our 3 primary trig ratios for this angle C. Let's figure out what we are given. So across from this 90 degrees here, this has to be our hypotenuse. Okay, so clearly we don't know that. There is no measurement there. All right, well, across from angle C here, well, this would be our opposite relative to angle C. Notice I'm saying relative to angle C. And then this one right here, this 4, this would be our adjacent. All right, well, we are trying to calculate the measure of angle C and also state the primary trig ratio. So let's do this part first. So this part, if we were to state the 3 primary trig ratios, our options are, well, not options, but they are, sine of angle C would have to be our opposite over your hypotenuse, okay? Well, in this case, we don't know what the hypotenuse is, but we have our opposite. We have 3 over, and we don't know the hypotenuse. So let's calculate it. Let's call this angle, or side length x. So in doing that, we can just use Pythagorean. That angle x is our hypotenuse. So that's like the c squared equals a squared plus b squared. Well, this would have to be x squared is equal to your other side lengths, 3 squared plus 4 squared. So x squared is then equal to 25. Take the square root of both sides, and you get x is equal to 5. So the side length here is 5. So that means our hypotenuse has a value of 5. All right, let's do the other one. Cosine of angle C is the adjacent over the hypotenuse. Sweet, we calculated the hypotenuse. Our adjacent relative to angle C is 4. Our hypotenuse was 5. And then we have tan of angle C. Well, tan of angle C would be the opposite side length relative to C over the adjacent side length relative to C, because those things can change. Opposite is not set in stone, or nor is adjacent. So, but in this case, relative to angle C, it's 3 over 4. And there you go. So now, calculating the measure of angle C, there is a special button on your calculator. If you find the buttons on your calculator, you'll see S, you'll see cosine, and you'll see tan. All right? Well, right above that, you'll see this button, sine inverse, cosine inverse, or tan inverse. Well, you use the purple, so use the inverse to find an angle. So if your angle is an unknown, then you use those. So these here. And then you use the function button to find a ratio, to find a side length. Okay, notice I just color coded it so it's easier for you to see. So would you use one of these? So in our case, it's asking us to solve for an angle. So we're going to use the inverse. So take any one of your three options here, any one of these three. Okay, they'll all give you the same angle C. It does not matter which one you use. So let's just choose this bottom one here. So tan of angle C is equal to 3/4. Well, to isolate for this angle C here, we need to apply the inverse operation, which is you taking the tan inverse of all of this. And you can't just do something to one side of an equal sign. You also need to then do it to the other. So this would be tan inverse. And then these cancel out, okay? And that gets you C tan inverse 3/4. So take your calculator and go shift or a second button, tan 3 divided by 4. And I get 36.87. And you calculate an angle, so degrees. Okay? Now let me just elaborate on this. You cannot, the reason you have to use these inverse button, because tan C, if this was 3/4, you are not able to divide and get rid of this tan right here by dividing by tan. That means nothing. Tan on its own means absolutely nothing. Okay? You cannot divide by tan. Please do never do that. The way you isolate for this the way you isolate for this angle, if the unknown is the angle, you need to apply your inverse operation. And we will do more examples of that, okay? So, in these problems right here, we're given an angle, and you're determining a side, or the ratio. You're determining the ratio of a triangle. So we have sine of an angle, all right? So this right here, this is the angle. So you're going to be using just the regular sine button. So you just type sine 25, and you get 0.4226. It wanted to go to 4 decimal places. That's why I went that far. And then on the next one, just hit the cosine button on your calculator, cosine 78.2. And you should get 0.2045. Right? Look for your tan button. Just hit tan 48. And you'll get 1.1106. So these, what you've just calculated, these are ratios. Ratios. Okay? That's a ratio. And what that ratio is, because in this problem right here, we're calculating the cosine, this is the ratio of an adjacent side length being divided by the hypotenuse. Because this is a sine, this would be the opposite side length being divided by the hypotenuse value. And this is a ratio that says, okay, your opposite and your adjacent, if you took those measurements and you divide them by each other, you would get 1.1006. That's what that represents, okay? So again, in example 3, it's just building on what we were doing before. In these problems right now, we're determining the unknown, which is the angle A once again. Okay, or sorry, just determining the unknown being the angle. So you need to solve for this. Again, I'll repeat. You cannot do this. You cannot divide by sine on both sides, because this sine A is not a multiplication. So this is not a thing. All right? I see that mistake so often. So the way you get rid of this, because our ultimate goal is we want A equals. That's what we want. All right? We're looking for that A. Well, you need to take the sine inverse, the opposite function of whatever this is, okay? So then take the sine inverse. And I ran out of room, so I'll just write it cleaner here. So it'd be the sine inverse of the sine of A. And these two are opposite operations. Just like when you take the square root of a squared number. these are opposite operations, okay? So you get then on the right-hand side, sine inverse 0.5326. And again, A, which is our goal, is equal to, now just take shift sine inverse 0.5326. So that's 32.18 degrees. Try it again over here. All right, and you actually don't, proper notation is you don't actually write cosine inverse on both sides, okay? So really, when you are trying to get rid of this cosine here, what you're doing is you are doing that operation. You're applying the cosine inverse, but math just says write the cosine inverse. You've essentially brought it over to the other side by applying it to being cosine. So as it crosses the equal sign right here, it becomes cosine inverse. So then it's cosine inverse 2/5, all right? That's just proper math notation. Cosine inverse 2 divided by 5, and your angle A, in this case, is 66.42. Once again, you are finding an angle when you use the inverse operation. All right. So use SOHCAHTOA to determine the measure of the indicated side or angle to the nearest tenth. All right, so let's look at the problem, what it's asking us to find, and what do we have given. That will allow us to figure out which ratio of the SOHCAHTOA we use. All right, so I see I have an angle here of 32 degrees. All right, well, I'm given two side lengths, or I see that there are two side lengths. I am given one right here, and I'm looking for this one right here. Well, relative to that angle 32, what is x and what is 28? Well, let's figure it out. I see I have a 90 degrees here. So opposite my 90 degrees would make this 28 my hypotenuse. And then if that's the hypotenuse, and this x right here is touching the 32, like this side length here is attached to that 32. That's what I mean by touching, attached. That would mean that this is the adjacent. So which ratio involves A and H, adjacent and hypotenuse? Well, that's the cosine ratio. So cosine of some angle, and in math, this is an unknown angle. It's a variable we use. We call it, it's theta. So cosine of an angle is equal to its adjacent over hypotenuse. So that means cosine of the angle given, 32 degrees, is equal to adjacent, which is the thing we are solving for, x, over the hypotenuse, 28. Now we're isolating for this x. So multiply both sides by 28. By 28. Let me get rid of this arrow. So these cancel, and you get 28 cosine 32 degrees. And that is equal to x. So 28 times cosine 32. X gives you, or sorry, x is 23.75. And the units are centimeters, so centimeters. Let's try part B. What do we have and what are we looking for? Well, what I'm looking for is this x right here and this y. So why don't we start by finding the y, okay? So I am given an angle of 43 degrees and a side length of 52.7. Well, that 52.7 relative to my given angle would make this my adjacent side length. And this y, right, it being opposite, would be my opposite So which ratio uses adjacent and opposite, sorry? Well, that would be the tan ratio. So tan of some angle would be the ratio of opposite over adjacent. So tan of my angle 43.5 degrees is my opposite, so the thing I'm looking for, y in this case, divided by 52.7. Now isolate for this y. So multiply both sides by 52.7, 52.7. This cancels with this, and you get 52.7 tan 43.5 is equal to y. Now just put that in your calculator. Tan 43.5 times 52.7 equals y being 50.0 meters in this case. So this is 50.0. All right, now let's find x. Well, relative to this angle, well, actually, not even relative to this angle, relative to this 90 degrees here, this is the opposite 90 degrees. This is your hypotenuse. So, which one involves adjacent and hypotenuse? Right? The reason I'm using adjacent is because I was a given angle here. Well, that's going to be my cosine. Cosine theta is measuring my adjacent over my hypotenuse. So, cosine theta is, 43.5 degrees is 52.7 meters, the one that was given to me, divided by my unknown. In this case, that was this x we were looking for. So in order to isolate for this variable, all right, it's just a little more, it's just an extra step of math. So we essentially need to get rid of this x on the denominator. So how to get rid of it on the denominator means we need to multiply both sides by x. Multiply both sides by x so that this x and this x cancel. So you have x being equal, x cosine 43.5 is equal to 52.7. Now to get x on its own, because that's what we're looking for, you need to divide by cosine 43.5. Again, that's a big thing. This is a mistake to a lot of people. You have to, this right here, this cosine 43.5, it's like one big number, okay? It's attached to it. This cosine is attached to the degree. So when you're moving this across the equal sign, when you're moving this from one side to the other, you have to divide everything by that, okay? So you have to divide everything by the cosine 43.5. You can't just bring out the 43.5. So this cancels, and you're left with x equaling 52.7 divided by cosine 43.5 degrees. And now just put that in your calculator. So say 52.7, divide that by cosine 43.5, and you get 72.65 and meters. Okay. Last problem. A hot air balloon on the end of a taut 95-meter rope rises from its platform. Sabrina, who is in the basket, estimates that the angle of depression of the rope is 55 degrees. So let's talk about this angle of depression. Like, what does that mean? Well, you have two things. You have angle of depression. So, angle of depression. And what that means is if you were, like if this is you, okay? And if you were looking straight ahead of you, okay? But then you saw something shiny on the ground. Let's say this is shiny. It's how far, of what angle, or what would you have to tilt your neck to look down and see that object. And the angle relative to the flat, so this is like the flat or the ground, the angle that you had to tilt your head at, this theta right here, this is your angle of depression, okay? So the other one is the angle of elevation. And that's saying, again, let's use you as an example. You know, you're standing here, and let's say you want to look up at a flagpole, okay? So you want to look up at the top of a flagpole right here. And so you have the ground, like you're standing on the ground. That's your relative flat point, all right? So the ground. So what would you have to, if you were just looking straight ahead, okay? So you're looking straight ahead, your sight is parallel to the ground. These are parallel, right? What would you have to tilt your neck up by to look and see the top of the flagpole? This theta right here would be the angle of elevation. So that's the two. You have angle of depression and angle of elevation. So let's use what was given to draw a picture of this scenario that's happening here. Let's read it one more time. A hot air balloon on the end of a 95-meter rope rises from its platform. Sabrina, who is in the basket, estimates that the angle of depression of the rope is 55 degrees. All right, so there is some platform, okay, that this hot air balloon launched from. And Sabrina, who is in the hot air balloon, so the hot air balloon being right up here. Let's see if I can draw a basket. There we go. Is saying that there is a rope connected to the platform. That rope is 95 meters long. Sabrina, who is in the basket, says that when she looks down to see that rope, so if her reference is the ground, when she looks down to see the rope, she looks down at an angle of 55 degrees. All right, so that's what we were given right now. How far to the nearest meter did the balloon drift horizontally? Okay, so you can see that this angle being 55 degrees here, all right, that's why I drew my picture like this off to the side, because if the balloon was right over the platform that you started from, right, if this was Sabrina here, and this is your reference, if she was right on top of it, she would look down and see the platform. She would be at a 90 degrees, right? Like looking straight down. So I knew that it was off to the side just based off the given angle of depression, okay? Well, the question is saying, well, how far has it drifted? So if this is where it started, this point right here, it's saying, well, let's draw a straight line up and across. How far has it drifted? So meaning, how far is this distance right here, this x? So let's find that. Think about what we have right now. And we can see that we've created a 90-degree triangle here, okay? You know, you've just gone up, and the ground is always flat, so that makes that 90 degrees. So if that's 90 degrees, this 95 would be the hypotenuse. And relative to that 55, this x right here would be the adjacent. So I'm going to be using the cosine ratio. Cosine of that 55 degrees, right, which is measuring adjacent. Adjacent would be the x over the given 95. So now isolate for x, so multiply both sides by 95. and you're going to get 95 cosine 55 degrees is equal to x, because these cancel. So 95 times cosine 55, that's going to give us a x of 54 we'll round it to just one decimal place, 54.5 meters. So therefore, the balloon, it's a word problem, the balloon drifted 54.5 meters horizontally, because it asked that horizontally. Well, how high to the nearest meter is a balloon? So part B. Well, how high up in the air would be this? We're looking for y now. Well, again, use what you have given. So this 55 and this y, well, this y is opposite of my 55. So if I'm going to use the hypotenuse being 95, and I'm now looking for a opposite, I'm going to be using the sine ratio. So sine of an angle is my opposite over hypotenuse. So sine 55 degrees is equal to my opposite, which would be y, divided by my hypotenuse, which is 95. So multiply both sides by 95 to isolate for the y. Multiply this by 95. So this cancels with this. So you get 95 sine 55 degrees is equal to y. So 95 times sine 55 is equal to, I'll put it up here, so y is equal to 77.82 meters. I think I rounded one to the bottom, so 8 meters. So therefore, the balloon is 77.8 meters high. Okay, last part. Viewed from the platform, what is the angle of elevation to the nearest degree of the balloon? Angle of elevation. So if you have this platform right here, right, and the balloon is up here, this is the balloon, and you are standing right here, angle of elevation, well, what would you have to look up to see that balloon? What angle would this be right here? Well, we know that that balloon, what we've calculated, that balloon, all right, is, what is it, x is 54.5, so 54.5, and we know that it is 77.8 high. All right, well, this ground right here, this dotted line I've drawn right here, it's the same horizontal distance, is it not, to get to this point right here? Or is it not that this distance and this distance here and here are the same with each other? They'd have to be. So we also know that then this right here is 54.5 meters. And we also know that this right here is 77.8 meters. So if I'm looking for this theta right here, and relative to this theta, this is the opposite and this is the adjacent, well, we can use the tan ratio. So tan of that theta is the opposite over the adjacent. So tan of this theta is equal to opposite 77.8 over 54.5. So now we are looking for this. So take the tan inverse of both sides. So theta is the tan inverse 77.8 by 54.5. And then you just calculate that. Shift tan inverse 77.8, divide that by 54.5, and you should get 55 degrees. And there we go. We will do a lot more word problems, all right? And there's lots of homework practice for them. If you were confused on this, please do your homework, okay? And I'll see you in class.